What am I going to talk about today? Scaling real-time communication. Wow. Sounds complicated. Yes. So I work at a company called Huddle01, and what we do is we build decentralized edge networks for high bandwidth workloads, which basically means we build um, software and infrastructure for folks to build real-time applications, which would include pub sub, messaging, video conferencing, live streaming, anything low latency, live media, or data transfer across continents. That's what we do in a decentralized fashion. And hoping to brief you on how the network was designed and the decisions we kind of made to make this work. So the core components are, there's the media node, registry nodes, and orchestrators. Media nodes are basically worker nodes which route and manage WebRTC traffic. So these are what the clients would connect to, and media nodes kind of take care of like worker nodes which kind of route WebRTC traffic. Registry nodes are kind of gateway or bootstrap nodes for the network to which all media nodes onboard to, and they use libp2p to like maintain a distributed ledger of all nodes. So that's where the fun stuff happens. And they're also tasked with not only onboarding the media nodes to the network, but also ensuring quality. We have stuff like proof of bandwidth and quality service assurances, which we will get into later. And orchestrators, they coordinate connections between nodes and clients. So there is a fairly complicated diagram on the right, which kind of talks about how everything kind of works. We use protocol schema, proto schemas and gRPC to maintain clear definitions of how each implementation should work. So people are free to make their own implementations. I'll go into a bit of depth of what each component does. So a media node is basically a wrapper around a WebRTC SFU, which is something which allows you to scale WebRTC connections across multiple clients at once. It also has a few modules like an API, RPC, QoS module. This is what our community and infrastructure partners run on high throughput, high bandwidth networks, and this is what kind of powers the network. So very high specs, like 1 Gbps up and down link are minimum specs for you to run it, and they have to be publicly addressable, which means either a static IP address or a dynamically changing one, but they have to be publicly addressable. This is what kind of powers whole of the network. And yeah, moving on to orchestrators. So media nodes are like worker nodes. They have no logic in them. Their sole goal is to take packets, duplicate, and route them. So because we wanted people to be able to define on, depending on their use case, on how they want to use this architecture, on the left you'll see the orchestrator design is where you're trying to do a live stream. So what you could do is you could arrange your media nodes in a fan-out manner where the streamer is connected to one SFU and the SFU or the media node is cascading the whole thing out to other viewers. So this is more of a fan-out approach. On the right, you would see a mesh topology approach where if you're doing something like video conferencing, you would ideally want the client to connect to the closest node and then hope for the network to take care of the communication, because once you're in the Huddle01 network, we try and optimize and use private networks, which means no public network hops and reliable packet transmission. So that would kind of lead you to a mesh type configuration here. So orchestrators are user defined. So people are free to design however system architecture depending on their use case, which kind of allows for a fairly usable and dynamic way to approach media transmission or data transmission through the best possible path. Okay, so we're talking about networking. Networking is pretty complicated. You play around with BGPs or border gateway protocols. Internet is not perfect, so you have to kind of take care of hairpinning and backhaul. So what is hairpinning? I have a very fun diagram which I was just making there. So this is Canada. So imagine you have a friend in Canada and friend in the US. When you're trying to send packets over the public internet, it's going through public internet hops where you see a very convoluted path the internet might take, and you have actually zero control over it. But when you want to do low latency stuff, what Web2 or the cloud does is they have their own data centers with their own private lines and private IPs through which they control their own BGPs. So the whole point of Huddle01 network is if people are hosting their nodes on multiple clouds or bare metals, we learn all of that data and we try and ensure that we are using those same private lines to allow for low latency communication. So this would be kind of the scenario where obviously this is theoretical. There are ocean cable fibers running there, but you have the lowest latency possible, which you would get on cloud, but is hyper democratized because it's decentralized and being run by the community and infrastructure providers. So yeah, moving on to registry nodes. So this is where I have a few P2P folks here. This is where the fun magic happens. So media nodes don't gossip to each other. Like I said, they're worker nodes. So all of the consensus and ledger maintenance which needs to happens on a smaller set of nodes called registry nodes. These are what take care of the health of the network by doing quality checks on the media nodes through quality assurance and bandwidth is on the next slide. And they maintain a DHT of nodes because the number of media nodes are in thousands. You need to maintain a ledger where the orchestrators can go and query which country or which continent has which nodes, and you get the information, dial the nodes directly, and connect to them. They're also responsible on maintaining the quality scores and hence also responsible for delivering incentives and rewards. What is quality of service? This is a fairly interesting challenge we had to face, is because we depend on highly reliable, high bandwidth nodes, and they have to constantly give out the same throughput and performance. We have to run randomized, extensive tests between nodes to check if they're, and kind of push them through congestion to check if they're actually supporting their claims which they're making on the bandwidth availability and the latency availability they have. And think of this as an overcomplicated way to do a speed test on your browser. But the issue is the network does not have access to Ookla or speed test because that would be like a centralized provider. So what you do is you make media nodes fight against each other and kind of let the best man win, but then you aggregate all of these scores and build like a reputation system and use that to allocate work and rewards. This is about the demand side. So today we'll see a lot of storage providers provide SDKs for folks to build, but I think we've been product first since the day one. We've already had SDKs in Unity, React, Flutter, JavaScript, even C#, I think. Yeah. And we also have a few products built on top of it, which has a few thousand users now and a few million minutes of usage. Yes. What's the goal of the network is to allow for anything real-time communication. Real-time AI is the new thing, decentralized inference, etc. But at the same time, if you're trying to do something like OpenAI where you're talking to the model live, the models are deployed in the US, but they're being delivered through WebRTC to you. So having a low latency communication fiber for all of these delivery use cases is pretty important. Like I said, because we were very demand first, we had the SDKs ready, and you can also run your own nodes and run a private network to do the same thing. And these are some images of programs and applications engineers have built on our community. Future work. So this is what I gave a talk on yesterday at P2P, where WebRTC is dying and you need a new protocol. The advantages for low latency communication are multifold, like you have multipath, multi-homing, streams and datagrams, and you can prioritize your streams. And now that you have web transport available, it unlocks a huge level of possibilities which were kind of bound to WebRTC, but UDP for the win. Thank you. This is all. I'm up for any questions. Oh, yeah, forgot. So, I wanted to show you all. Can we have a camera on? Guys, turn on a camera. I just wanted to show you all the actual product running on decentralized infrastructure. This is our team. And I think Darshan is from Mumbai. We're in France right now. And if I go to network stats, that's 27 milliseconds. So there's a node being run in Europe, in France, I think, maybe in Paris, and that's 27 milliseconds. Darshan would have a very good latency because we have a node in Mumbai. And there are so many people, I hope they turn their cameras on. Guys, turn your cameras on, you're live. We only have like 30 seconds left. Oh, let's go. So yeah, that's that. Any questions? I think everyone's just happy looking at faces. Okay then, thank you.
Applause.
Bye-bye.